Today we're going to take a look at the topic 5 review. We're going to cover all 5 lessons because that's what we did over class over the last, 5 weeks. The first thing I want to emphasize is that our solutions manual that's inside the module for this week in Canvas has the answers for these vocabulary reviews. We've kind of hit on this every single week that vocabulary is kind of a new thing with this unit. There's a lot of new words that we've never seen before. So what I would highly recommend you do, open up that solutions manual and make sure you are comfortable with what each vocab means as well as the definition for them, okay? Lesson 5.1. This is where we'll start. Quick review: perpendicular bisectors and angle bisectors are related to the segments or angles they bisect. Kind of goes without saying. Any point on the perpendicular bisector of a segment is equidistant. That's just a fancy word for saying it's the same distance from the endpoints of the segment. Let me kind of draw you a picture real quick what that's saying. So if I have a line segment, there are my endpoints, call them A and B. If I construct, right, if I create a perpendicular bisector, what that means is perpendicular says that this line is going to come off of that line segment AB at a 90-degree angle. It comes straight up in the air. Perpendicular bisector, so bisector means that it's taking this line segment AB and it's cutting it in half perfectly. So the left side is going to be the same distance as the right side. So what this was saying is that any point on this perpendicular bisector, doesn't matter where the point's at, that point is going to be the same distance from A as it is to B. Any point. Any point on the bisector of an angle is equidistant from the two sides of the angle. So same kind of situation. If I create myself an angle, so here's my vertex, we'll call it A. My vertex is A. If I create an angle bisector, that angle is basically going to cut this angle A. It's going to cut that in half perfectly. So the left side is the same value as the right side, okay? And what this definition was saying is that any point on this angle bisector, any point, I'm just picking that one there, it's going to be the same distance from that point to this side as it is from that point to this side. Same distance. In this example is just kind of emphasizing that here. So here is my base, right? Call that AC. The red line is my perpendicular bisector. And the way I can tell that is the two parts, perpendicular and bisector. That red line comes off of AC at a 90-degree angle. You can see they're telling you that right there. And then it bisected AC in half. The left side is 10 and the right side is 10. So this is a perpendicular bisector. Find AB. So they're looking for the length of this side here. So now that we know it's a perpendicular bisector, we know some things happen, right? We know that the left side is equal to the right side. We know that any point on this perpendicular bisector is the same distance from that point to A as that point to C. The other thing we know is because this is a perpendicular bisector, this line BC has to be the same distance as this line BA. They have to be the same value. They're actually giving you BC is 36. So what you know is that BA has to also be 36. Now we'll jump over to number 8. Use the given values to find each unknown. So for me, it really helps to sketch this out and to kind of start labeling things. If you can just envision this and assign all these values to all these different line segments, that's totally fine. But if it helps you to sketch this back out, feel free to. So if PS is 36, so that line segment is 36. PQ is 3x plus 5. So this line segment right there is 3x plus 5. QR is 6x minus 10. So the other side of that is 6x minus 10. And RS is 36. So this side length is 36. Then find PR. So they want the entire distance. So we know the pieces, right? But they want the entire distance. The thing with this is they're going that this is a perpendicular bisector, right? We know that because that 90-degree angle there. And again, like we just talked about over here, if this is a perpendicular bisector, I know that each of these segments are the same. So what I'm going to do is I'm going to set PQ equal to QR. PQ is 3x plus 5. QR is 6x minus 10. So for number 8, PQ, let me go back and look. PQ is 3x plus 5. And then QR is 6x minus 10. Again, just like we talked about here, the left side and the right side have to be the same. So since they're the same, I can just set them equal to each other. Now I'll go ahead and solve. So I'm going to subtract 3x from both sides, and I'll also add 10 to both sides. So 6x minus 3x, that's going to be 3x. If I add 10, that's 15. If I solve for x by dividing both sides by 3, I get x equals 5. I don't think they were asking for x though, right? They were asking for the entire side length. So they want this entire side length. So what I can do is I can just plug this in and solve, because each side is, they're giving me an expression. So PQ is 3x plus 5. QR is 6x minus 10. So the entire side length is basically going to be both of those added together, or you could just input x is 5 and then double it. Maybe that's what we'll do. If PQ is 3x plus 5, then I know the entire side length, PR, is going to be 2 times that side length. PQ is 3x plus 5. 3x plus 5. Okay. So I found out that x is 5. So I'll do 2 times 3 times 5 plus 5. 3 times 5 is 15. 15 plus 5 is 20. 2 times 20, that's all PEMDAS, right? Order of operations. 3 times 5 is 15. Now we're still inside parentheses. 15 plus 5 is 20. Now I have 2 times 20 is 40. So there we go. That's our final answer. PR is 40. 40. I don't know why I said 40. 40. 9, I think they're using the same thing. So we're going to use that same picture. PS is 4x plus 8. So that side is 4x plus 8. PQ is 29. So that base right there is 29. RS is 5x minus 3. So that side is 5x minus 3. And then QR is 29. Find PS is what they're looking for. So they want us to find the actual value. I know it says PX is 4x plus 8, so don't think it's 4x plus 8. We're going to actually have to solve for x and plug it in. So overall, that's what we're looking for is PS. Let's go back to this example right here, because question 9 and this example go hand in hand with each other. They're telling you that these two bases right here, PQ and QR, are the same. 29 and 29. So what that tells me is that this is a perpendicular bisector. If that's the same, then we know that these two side lengths have to also be the same. So PS is 4x plus 8. RS is 5x minus 3. If those two side lengths are the same, very similar to what we did in number 8, we can set those two equal to each other. So PS is 4x plus 8. 8, and that will be equal to RS 5x minus 3. And now I just solve. So I'll subtract 4x from both sides. Since I'm moving my x's to the right, I'm going to go ahead and add 3 to both sides to move all my constants to the left. So 8 plus 3 is 11. 5x minus 4x is x. So what I find out is that x equals 11. Again, we're not solving for x. That's just kind of a stopping point here. We're looking for PS. They're saying PS is 4x plus 8. So PS is 4x plus 8. Since I know x is 11, I can do 4 times 11 plus 8. 4 times 11 is 44. 44 plus 8 is 52. So PS is 52. If JM, so this side length is 12, LM is 12, and measure of angle JMK. So the way you read this, JMK, the middle letter is always the angle you're talking about. So JMK. So I'm looking at this left side of that angle right there, JMK. JMK is 25. Then the measure of KML, which is the other side, KML, so it's the right side, is what? Well, again, just like we've talked about, if those two bases are the same length, they're both 12, we know what's happening here is that the angles is this is an angle bisector. If both of those angles are the same length, then we know that both of these angles, I'm sorry, I think I said angles. If both of these sides are the same length, then we know that both of these angles are the same measurement, okay? So if this angle is 25, then we know that KML has to also be 25. Number 11, same picture. If the measure of angle JML, so JML, if that's 49 degrees, so you're talking about both of these little sides here, don't worry about that angle bisector, just both sides added together, the entire thing is 49. The measure of angle JMK, so basically the left side of that angle, is 24.5, which just happens to be half of that angle amount, right? Half of 49 is 24.5. What that's telling you is that MK is an angle bisector, right? This is cutting this angle M, in half perfectly. The left side is 24.5 and the right side is 24.5. They're saying that JK is 17. So this distance here, that's 17. Then KL equals what? Well, we talked about earlier over here in the quick review that if MK is an angle bisector, then any point on MK has to be the same distance from that angle bisector to the side. What you'll notice is that JK is at a 90-degree angle to the side. KL is at a 90-degree angle to the side. So those two distances have to be the same distance. So if JK is 17, KL has to be 17. Number 12, a point on a perpendicular bisector is 7 centimeters from each end point of the bisected segment. So what they're saying here is this is my bisected segment. The point on that perpendicular bisector is 7 centimeters. So that distance is 7, that distance is 7. And 5 centimeters from the point of intersection. So what they're saying there is that this distance, right, this distance down the middle is 5 centimeters. To the nearest tenth, what is the length of the segment? I think this is going to require Pythagorean theorem. We know if this is a perpendicular bisector, we know that these two triangles here are right triangles. So we can use a squared plus b squared equals c squared. The only thing here, you can plug in these two sides. It doesn't matter which legs you plug into which side, but this has to be your hypotenuse. Has to be. So this is number 12. We didn't need number 10. Number 12. Again, we're using this picture here. The distances there are 7. We know that those are my hypotenuses, right? Because those are opposite the 90-degree angle. So with this formula, c squared, that has to be 7 squared. So I'll put it like this. It doesn't matter which one you use for A and B. Doesn't matter which leg. I could use 5. I think this is what we're looking for, is that distance there. Let's just make sure. To the nearest tenth, what is the length of the segment? So they're talking about the entire segment here. So we'll find half of it and then we'll just double it for the entire segment. So I could use 5 squared plus x squared. I could use x squared plus 5 squared. It doesn't matter where you plug in those two pieces of information. So I'll use x squared plus 5 squared. And again, if this is my picture, I think what they're looking for is the entire length of that segment. This is my perpendicular bisector. The distance from that point to A, as well as that point to B, is 7. And then the overall height is 5. So what we're finding here is this side right there, and then we'll double it to get the entire side. So here I've got x squared plus 25 equals 49. I'll subtract 25 from both sides, and I get x squared equals 24. Take the square root of both sides, and then I get x equals, I'm going to leave it as positive or negative root 24 for now. What this is telling me is that this side length can either be positive or negative root 24. Well, keep in mind, if you're talking distance, if I walk from my table to the front door, I can't walk negative 20 feet, right? So when it comes to distance, you're kind of throwing out the negative answer. You're only keeping the positive distance. So the square root of 24, this is going to be a decimal. Let me get my calculator out. 24 square root. I got 4.8989. I think they said to round to the nearest tenth. So I'm going to write this as x equals 4. I should write it like this, actually. X is approximately, because we rounded it, 4.9. So that's the rounded version. Keep in mind, this is just that part there. So I need to double it to get the entire segment. So 4.9 times 2, I would say x is approximately 9.8. All right. Lesson 5.2, bisectors in triangles. So again, a quick review. The perpendicular bisectors of a triangle are concurrent at the point equidistant from the vertices of the triangle. This point is called the circumcenter, okay? So perpendicular bisectors, here's an example of that. They're created a perpendicular bisector here, here, and with this side here. They're calling this, that's that point, point A. It's concurrent. So that just basically means they meet up, they cross, they intersect at point A. So this point there with the perpendicular bisectors, that point is called the circumcenter. So this is what I'm talking about with vocab. Either in your notes or in your brain, if you can remember this. I have a hard time remembering this. But make sure you're connecting those two, that they go together. When you do a perpendicular bisector where those intersect, that's called the circumcenter, okay? Because here's another one. Angle bisectors of a triangle are concurrent, which again just means they meet, they cross at a point equidistant. That's just the same distance from the sides of the triangle. This point is called the incenter. So here's that example. There's all my angle bisectors. That point, point K, is called the incenter. And just like they're saying, that point is concurrent, right? All three of those angle bisectors meet at point K. And that point is equidistant from the sides of the triangle. So from K to this side, from K to this side, from K to this side, those distances are all the same. So look at this example for triangle ABC, which is the big one right here. What is the radius of the inscribed circle? So that's the circle on the inside here. They're saying that DF is equal to EF. Let's take a look. DF right? That distance, F is that the center of that inscribed circle. So DF, that distance, is equal to EF, that distance. They're saying here there's a lot going on, but they're saying here that DF is 3x. They're saying that EF is 2x plus 16. Well, if we know that the center of that inscribed circle, it's the same distance from that center to each side, well, then those two values have to be equal to each other. The distance is the same. So what I can do on paper is I could just set 3x equal to 2x plus 16 and solve it. So they end up with x equals 16. They're looking for the radius, so they're not looking for x. So you can plug that into either one of these. 3 times 16 is 48. 2 times 16 is 32. 32 plus 16 is 48. So the radius, the distance from the center of that circle to the edge, is 48. So just make sure you're connecting all these ideas together. For example, perpendicular bisectors and circumcenters go together, right? Angle bisectors and incenters go together. The distance between the circumcenter and then each of the angles, each of the vertices, as well as the incenter and each of the sides, those distances are all equal to each other, okay? So make sure you understand that. Let's take a look at 13. Identify each point of concurrency. 13 is the incenter, so we're looking for the incenter. Again, come over here, so we're looking for the angle bisectors. These are perpendicular bisectors. You can tell because they have each side. Each side is labeled with 1 tick mark, 2 tick marks, 3 tick marks. And then those dotted lines are coming off of those sides at a 90-degree angle. So this is a perpendicular bisector. This is a circumcenter. This right here, you can see that these dotted lines are cutting those vertices in half. There's 3 tick marks on each side, 1 tick mark on each side, 2 tick marks on each side. So this is an angle bisector, which means that that point K is an incenter. So I think what they're looking for 13, they want you to answer point K. And then for circumcenter for 14 would be point A. Use the diagram to find each of the unknown quantity. If the measure of angle GFL, right? GFL. So they're looking for this little angle down here. If that's 34, the measure of angle GEL, so GEL, so that little angle up top here, that is 36. What's the measure of angle FGL? FGL. So they're looking for that angle right there. So this is an interesting problem. It's not outright giving you every single piece of information and kind of spoon feeding you to the answer. You've got to kind of know what you're doing. Basically, the main thing is that you're bisecting angles here, and what that means. It's cutting that angle in half perfectly. So I'm going to do my best to kind of draw a little bit of a picture here so that way we can. So E, F, G. They're calling this L. So that. Oh, okay. Again, excuse my crappy drawing, right? But we'll get the point. The measure of angle GFL. GF, and this was point L. Okay, GFL is 34. So that means that's 34 degrees. Measure of angle GEL is 36. GEL, so that's this right there is 36. What is the measure of angle FGL? Okay. So with this picture, one thing you'll notice is that each of these, this is an angle bisector. It cut angle F, the entire thing, it cut it in half perfectly. So if this side is 34, That means that side has to be 34. It cut angle E in half perfectly. So if that side is 36, this side has to be 36. We know triangles add up to 180 in total, right? So if I'm looking at this large triangle, it looks like angle E, 36 plus 36 is 72. Angle F, 34 plus 34 is 68. So all I have to do to find angle G is just subtract my knowns. So subtract 72, and that gives me 108. Then I'll subtract 68, and that gives me 40. So what that tells me is that angle G is 40. The entire thing is 40. The measure of angle FGL, FGL. So all you're looking for is 1/2 of that. So 40 divided by 2 is 20. So the measure of angle FGL has to be 20 degrees. So this was number 15. Same picture, so hopefully we have enough, we didn't mess this up too much so I can use it again. If JL is 5, so JL, that's this right here, JL. If that distance is 5, what is the measure of KL? K is right there. So there's KL. So what they're saying here is if this distance, JL, is 5, basically, what is KL? What's the measurement of KL? Let's go back and look at, again, our two situations here. We have perpendicular bisectors that give you a circumcenter. We have angle bisectors that give you an incenter. So what they're essentially saying is that L is my incenter. Well, remember, it says right here that any point is equidistant from the sides of the triangle. So any point from L, right, my incenter, that distance between L and J is 5. And again, my picture sucks. But then this distance from L and K has to also be 5. Distances are the same. 17, the circumcenter. So we're up here again, we're dealing with perpendicular bisectors. The circumcenter of a triangle is on one side of the triangle. Explain how to find the area of the circumscribed circle of the triangle given the lengths of the side. So this question is connected to, let's go back and find it, 5.2. 5.2. 5.2. Let's see. I think I might be thinking of a different problem. Yeah, I must be. Never mind. I was thinking of a different lesson that had like a picture or a diagram of what I wanted to say. So with this example, I kind of wanted to give you a picture of what they're talking about here, where that circumcenter is going to be on the side of a triangle. So let me see if I can get this. Now I'm jacking up my picture. So this is just a website that I've used, over the years, even in college math and stuff, just called Math Open Reference. I'm sure there's other things out there, but I just Googled it to play around with this because this is a cool feature. And what you can see is here are all of those perpendicular bisectors. You can see all those lines, they look reddish. What they want is that circumcenter to be on one of the sides. So if I can click this and start playing around with it, you can see the circumcenter kind of moving in the middle of the triangle. But if I try to place it on a side, which looks like it's about right there, what kind of triangle does it form? Well, it doesn't outright say it at angle C, but this is a right triangle. So the only way for this to happen where that circumcenter is on one of the sides, specifically the hypotenuse, is if you have a right triangle. I think, let's see if special case right triangles, I bet you this is it. In the special case of a right triangle, the circumcenter C right there lies exactly at the midpoint. So it's right in the middle of the hypotenuse. So they're just trying to get you to look at a special case type of triangle here. So let me zoom back out and kind of get a better picture here. So for number 17, the circumcenter of a right triangle, that's the only way it's going to lie on the side of the triangle. Explain how you can find the area of the circumscribed circle of the triangle given the lengths of the sides. So in a situation like this, we know that the area of a circle is pi r squared. So the missing piece of information, pi is just a number, r, the radius, that's what I'm missing. That's what I would have to know to calculate the area of this circle. Well, like we talked about on that website, not only are we dealing with a right triangle, but that circumcenter is actually going to be at the midpoint of your triangle. So something like this. There's my right angle. There's my midpoint, I'm calling it, right? So that circumcenter is point X. And again, it's at the midpoint of that hypotenuse, the side that's opposite the 90-degree angle. So if I know that, well, that's enough information. Of course, not with this problem. We don't actually have values, so we can't calculate it. But it's just going to be half the distance of this hypotenuse. So if I inscribe a circle, it's just going to be whatever this distance is between X, between that midpoint and one of those endpoints. That'll be half that distance. Remember, the distance across a circle, that diameter, right? That's the entire distance, but radius is only half of it, okay? All right, so we're gonna go ahead and go to 5.3. Quick review. So this is all about medians and altitudes, more vocab, right? Make sure, just like with 5.2, you connected perpendicular bisectors and circumcenters with angle bisectors and incenters. Same thing's happening here. If you're dealing with a median, you should be thinking a centroid. If you're dealing with an altitude, you should be thinking an orthocenter. They go hand in hand, back and forth. So a median of a triangle is a line segment from the midpoint of one side to the opposite vertex. Let's see if I can find one. Here we go, right here. WF, that's what we would call a median. So here's my side, DE. W is the midpoint because the left side is the same distance as the right side. So W is at the midpoint. And then the vertex that's opposite that side, not the two vertexes that it contains, but the opposite vertex is point F. So WF is an example of a median. The medians of a triangle are concurrent. So if you graphed a bunch, 2 out of the 3 medians, you don't need all 3, just 2 of them will tell you where it's at. The medians of a triangle are concurrent. They meet at the centroid. So here, we don't have an example here. But if I did another median from EF right there across to vertex D, wherever those 2 lines, WF and this line would cross, that would be called my centroid. The distance from a vertex to the centroid is 2/3 the distance of the median from that vertex. So actually, I think I'm gonna draw a picture here. So here's my triangle. I'm going to say that to this vertex. Okay. So this is a median, right? It cuts that line segment in half perfectly, and then it goes over to the opposite vertex. I'll say that this, of course, I'm just hand drawing these, so they're not perfect. So we'll call this point D and this point E, okay? So EC is a median, and then DB is a median. The point where they cross right there is what they're referencing as the centroid, okay? So that's my centroid. The distance from a vertex to the centroid, so the distance from this vertex, so from here to here, is 2/3 the entire distance. Okay, so from the vertex to the centroid, that is 2/3 that distance. So if this entire distance, if BD, if the entire distance was 6, then the distance from B to my centroid there would just be 2/3 of that. So let's call this F, just so we can label it. So BF would be 4, 2/3 of 6. Make sure you're measuring or you're evaluating from the vertex to the centroid. That's the distance that's 2/3. So this distance over here would be 1/3. An altitude. So an altitude of a triangle is a line segment perpendicular to one side and ending at the opposite vertex. So sort of similar to a median, but it's not bisecting that side. It's just coming off of it at a 90-degree angle. So ending at the opposite vertex. The lines containing the altitudes of a triangle are concurrent at the orthocenter. So again, let me see if I can draw a little bit of a picture. Call that ABC. So we would say with this picture, let's focus on my vertex C. So what we're referencing here, these altitudes are going to run from the opposite side to the opposite vertex. So in this case, it would look something like this. The only stipulation is, notice that AB is not being cut in half. It doesn't really matter what the lines, what the distances are. The rule is that this altitude has to meet that side, AB. It has to meet it at a 90-degree angle and come off and then hit the opposite vertex. So same thing with B here. Let's say that. It might look like it bisects that side, but we don't know for sure. All we know is that this line segment comes off of AC at a 90-degree angle, and then it hits the opposite vertex, okay? So that point where they cross is what they're talking about as the orthocenter. I don't need to actually plot all three. 2 out of the 3 is fine, because once I plot this third one, they should cross if my picture was good, okay? So that point where they're crossing is called the orthocenter. Let's make sure I didn't miss anything else. Any of the lines containing the altitudes of a triangle are concurrent at the orthocenter. So we already talked about that. So the example, Q is the centroid, right? So again, feel free to go back up here and look at these vocabs. Centroid and median go hand in hand. Q is the centroid of XYZ. If DZ, so the entire length there, is 24, what is QZ? Now remember, the distance from the angle to that centroid, that's 2/3 of the total distance, okay? So if this entire distance there is 24, 2/3 of 24 is 16. So that means DQ down here, that's gonna be 1/3 of it, so that's 8. QZ will be 2/3 of 24, which is 16. If you're not comfortable with that, just take a calculator. 2/3 of 24, that's the same thing as 2/3 times 24. So you can get the value that way as well. Identify each segment type. So it looks like they're giving us 2 lines here. This first one, we'll talk about WF first. That's going to represent the median. I know that because it's cutting the line segment DE in half, where DW is the same length as EW. And then it's going from that midpoint over to the opposite vertex. So WF would be the median. So that's 18. And then EX would be the altitude. The way I know that is because that line segment DF, EX is coming straight off of that line segment at a 90-degree angle. It's not indicating that it's cutting that in half perfectly. We don't really care about those values. It's just indicating that EX is coming straight off of that line segment at a 90-degree angle, and then it's hitting the opposite vertex, E. So for 19, it would be EX. Find the orthocenter. We skip these in our lessons, so we are skipping them as well. Not because you can't do them, but because it involves multiple other skills, like creating a line given 2 points using point slope formula. Once you create these two lines, you can set them equal to each other to find the point of intersection, and that's what they're looking for with the orthocenter, is the point of intersection. It's a little bit of a complicated process, not super hard, but just because we're in online learning, we're going to go ahead and skip that. So just ignore 20 and 21. 22, the orthocenter. So again, we're dealing with altitude. Orthocenter is the points where all the altitudes meet. The orthocenter of ABC is point B. So they're not actually giving you a picture of that. I think this picture actually belongs down here, so ignore that. The orthocenter of ABC is point B. What is the measure of angle ABC? So if the orthocenter is point B, what's the measure of angle ABC? I'm going to go ahead and sketch a picture of this real quick. So I think this is the one that I was trying to find earlier. So let's go back to 5.3, 5.2, 5.3. Here it is right here. So with 5.3, this is that example I was trying to find earlier in 5.2, but it was in this lesson. It's talking about the orthocenter and how you can be dealing with 3 different types of triangles: an obtuse, an acute, and a right. So remember, obtuse basically means it's greater than 90 degrees. Acute means that they're less than 90 degrees. And then right means that one of the angles are 90 degrees, okay? So if this is the case, an obtuse triangle, the orthocenter is on the outside. An acute, the orthocenter is on the inside. And a right, the orthocenter is always going to be on that 90-degree angle, okay, if you're dealing with a right triangle. So I think this is where they're trying to get at with 5.3, number 22. If the orthocenter of triangle ABC is point B, so this is just, again, another crappy drawing. If the orthocenter is right there, right on that, then we know, again, it should look something like this. A, B, C. If that point is on point B, then just like that piece in 5.3 was talking about, if it's on that point, then this has to be a right triangle that has to be 90 degrees. So question 22 was just referencing, I think it was example 4 and 5.3. So feel free to either sticky note that section or just keep that in your notes where you're dealing with an obtuse, acute, and a right triangle and where that orthocenter is going to be. 23, a plastic triangle is suspended parallel to the ground. So that means that side right there is parallel to the, if this is grass down here, it's parallel to the ground, by a string attached at the centroid. So again, centroid, we're dealing with the medians. So we know what we're doing is we're bisecting each of these sides, and where those bisections meet, that's that centroid. Copy the triangle and show where the string should be attached. So everybody knows my drawing skills suck, but I'm going to do what they're saying. So let me see if I can copy this triangle. And that's like this. Okay. So it's going to look something like that. And then they're saying like, this is my ground. So basically this side and the ground are parallel to each other. They want to kind of roughly identify where that centroid's at, right? And again, centroid goes with medians. So we know what we're doing is we're taking each side length and we're cutting it in half. And then those side lengths are going to go to the opposite vertex. So I'm going to go ahead and label this A, B, C. If I'm looking at my side length AB, if I cut that in half, looks like about right there. That means that the left side will be the same length as the right side. And then that line is going to go to the opposite vertex, which is C. Do the same thing for BC. That looks like about my midpoint, where the right side is equal to the left side. And then we're going to form a line from the opposite vertex, point A, to that midpoint. And that's enough. If you wanted to do AC, bisect that side, go to the opposite vertex, you could, or bisect that side, go to the opposite vertex, you could, but it still will cross at that same point. So the only benefit of doing the third side is just verifying that you did the other two correctly. Just by doing the 2 out of the 3 sides, that's our point right there. So they're looking for where that string should be attached. So there is my centroid right there. The string should be attached right there. 5-4. So now we're getting to more recent stuff. Inequalities in one triangle. In a triangle, if 2 sides are not congruent, then the larger angle is opposite the longer side. Keep that in mind. Make sure you're paying attention to the wording here. Angles are larger and smaller. Sides are longer and shorter. Okay? So don't say that an angle is shorter or a side is smaller. You know, you want to talk about shorter and longer versus smaller and larger. Okay? Just a small detail. If 2 angles are not congruent, then the longer side is opposite the larger angle. Basically saying the exact same thing. If you're dealing with a triangle, and you're looking at these 2 sides right there, those 2 sides, this looks like to me, this is the shorter side. So let's call that 5 and let's call that 8. If this is the shorter side, then that means that this is the smaller angle. If this is the longer side, then this is the larger angle over here. Okay. Same thing with the second part of what they were saying there. So let me see if I can draw this triangle again. Here they were talking about opposites of sides. If this is the shorter side, this is the smaller angle. If this is the longer side, this is the larger angle. And the same thing could happen. If this angle is 18 and this angle is 45, well, since this angle is larger, now I got to watch my words. If this angle is larger than this angle, then this side is longer. If this angle is smaller than this angle, then the side opposite that is shorter. So that's what it's essentially saying. XY is greater than XZ, which is greater than YZ. The measure of angle Z is greater than the measure of angle Y, which is greater than the measure of angle X. So with this picture right here, they're telling you that YZ is the shortest, XZ is the second longest, and then XY is the longest. Okay, so that's why they're saying here, XY is the greatest, then XZ, then YZ all the way at the bottom. So then you can relate the angles to those as well. So if YZ is the shortest side, then angle X will be the smallest angle. If XY is the longest side, then the angle that's opposite that side, angle Z, will be the largest angle. Then the last part, the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. If it's not a triangle. It won't meet. And just to, again, draw kind of a crappy picture, if you have the situation they're talking about, it'll look something like that. You'll have a gap. You won't be able to connect all 3 vertices. So. And that's essentially what they're saying here. They took 4 plus 5. Those 2 sides have to be longer than the third side. Then they took 4 plus 7. Those 2 sides added together have to be longer than the third side. Then they did 5 and 7. Those 2 sides have to add together to be longer than the third side. So for this example, which side of triangle TUV is the longest? We know triangles add up to 180. If this is 71 and this is 52, that means that 180 for the whole thing minus 71 is 109. 109 minus 52. Ooh, my brain's getting fried. Let's do it on my calculator. 109 minus 52. 109 minus 52 is 57. So angle V has to be 57. They all three have to add up to 180. So I started off with 180. I subtracted 71. I subtracted 52, which means angle V has to be 57. If this is 57, they want to know which side is the longest. Well, the only way I'm going to be able to tell that is it's going to be the side that's opposite the largest angle. If this is 57, that's 52, that's 71. Angle U is the largest angle. So the side opposite angle U has to be the longest side. So VT has to be the longest. 24, determine if the lengths can form a triangle. This goes right back to this part right here, the review, where if you add any of the two sides, they have to sum larger than the third side. So 14 plus 32 is definitely greater than 18. 32 plus 18 is definitely greater than 14. And then 18 plus 14, those two end pieces, when you add those together, that actually equals 32. So no, it has to specifically be greater than 32. So 24 will not form a triangle. 25, same thing. I'm just adding two of the numbers to see if they're greater than the third. 14 plus 25 is definitely bigger than 29. 25 plus 29 is definitely bigger than 14. 14 plus 29 is definitely bigger than 25. I don't care what the sum is, just as long as it's bigger than that third number. So 25, good to go. 26, 37 plus 52 is 59. So it's getting close, but it's still greater than that. So we're good. 22 plus 56 is definitely bigger than 37. And then 56 plus 37 is definitely bigger than 22. So 26 is good to go. 27, 87 plus 35 is bigger than 41. Cool. 35 plus 41 is 76. 76 is not bigger than 87. So right off the bat, 27 cannot be a triangle. Use this figure for 28 and 29. Which angle has the least measure? So the smallest measure. Again, just remember the relationship here. The smallest side is going to be opposite the shortest side is going to be opposite the smallest angle. The longest side is going to be opposite the largest angle. So they're asking for the least measure. PR is the shortest side, so angle Q will be the smallest angle. Which is greatest? PQ is the longest side, so the vertex that's opposite PQ, angle R, will be the largest angle. Number 30, why must the sum of two sides of a triangle be greater than the third? Well, I kind of drew a picture here earlier, but let me draw it again. If I said that this side was 8, this was 6, and this was 4, right? I don't know if this is going to work. So let's check it out. I'm just making up numbers here. Let's check them. So this actually does work. So let me change that. I'm going to change this to 1 because I want to make it not work. If these were my 3 side lengths, I would do 8 plus 6 is 14, definitely bigger than that third side, so we're good. 6 plus 1 equals 7. 7 is not bigger than that third side, so that would fail. And this is the picture that we'd have. We'd basically have a side length where it was short. You'd have a gap. You wouldn't actually connect all 3 sides of this triangle. And then 31, 2 sides of a triangle garden are 6.4 and 8.2. The gardener buys fencing for $29.25 per meter. What is the range of total cost of the fencing? So just like a lot of times in math, drawing a picture tends to help. So for 31, it's a triangular garden. So I don't know if this is going to look correct or not, but I'm just drawing a random triangle. They said that one side was 6.4, one side was 8.2. And then we don't know the third side because what they're saying is they bought fencing to fence this in, okay? And then we need to find basically the domain, how far, what's the minimum amount as well as the largest amount that we need to buy. So the gardener buys fencing for $29.25 per meter. What is the range of total cost of the fencing? So this is the one where you're gonna set up kind of a triple part inequality at the end. So it's going to be X plus 8.2 equals 6.4. So I added those two together for the third side. And then I will add these two together. So it's going to be 8.2 plus 6.4 equals X, because those two sides have to be greater than, I don't know why I'm writing equals, they have to be greater than the third side. So those two sides, when I sum them together, have to be greater than the third. And then I'll do the last set, which is X plus 6.4, have to be greater than the third side, 8.2. So now I'll go ahead and solve. Here, if I subtract 8.2 from both sides, I'll end up with X is greater than 6.4 minus 8.2 is negative 1.8, I believe. Let me just double check myself. 6.4 minus 8.2, negative 1.8. So, I hate just scratching stuff off. I'll do it though. X is greater than negative 1.8. So that one is done. The next one, 8.2 plus 6.4, that's 14.6. So instead of writing 14.6 is greater than X, I'm going to flip-flop them. X is less than 14.6. And then my third one, if I subtract 6.4 from both sides, I'm going to end up with X is greater than 1.8. Okay. Well, if we're talking distance here, I think we talked about it earlier. I don't care about the negative distance, right? There's no such thing. So in this case, we're saying X has to be less than 14.6 and it has to be greater than 1.8. So the way we'd write this is 1.8 is the smaller of the two numbers. X has to be larger than that. And then that can go all the way up to 14.6. So that's how you can combine these two things into one. Start off with your smallest number, less than X, less than the largest number. So what is the range of the total cost of fencing? It depends on how far you want to round this. Let's round it, since this is talking about money, let's round it to the cents, right? It's got to be strictly greater than 1.8. So we'll say all the way from $1.81, and then it has to be less than 14.6. So all the way up to 14.59. So from $1.81 all the way up to $14.59. And then our last lesson, inequalities in two triangles, very similar to 5.4. The hinge theorem, which, to be honest, I don't think I've ever even heard until we started this book. The hinge theorem states that if two triangles have two congruent sides, the two sides are the same length, and the included angles are not congruent, then the longer third side is opposite the larger included angle. Okay? So the hinge theorem states, and I'm going to go ahead and go back to 5.5 just because I know there's a picture of this instead of me trying to draw it and get it all jacked up. So here's the thing right here. If two sides of one triangle are congruent to two sides of the other, so WY is congruent to AC, WX is congruent to AB, and the included angles are not congruent, so angle W is not the same angle as angle A, then the longer third side is opposite the larger included angle. So let's say angle W is a larger angle than angle A, then that means the side that's opposite angle W, XY, is going to be a longer side than the side that's opposite angle A, BC. So that's what they're talking about. So example, order A, C, D, F, and G, J from greatest to least. So let's take a look. They're saying that AB is congruent to DE, which is congruent to GH. And then they're saying BC is congruent to FE, which is also congruent to HJ. Okay, 2 tick marks go together, 1 tick marks go together. If this side is X on this side, this angle, angle B is X, the angle that joins those two sides, if that's X, if the angle that joins these two sides is X plus 5, what's that saying is that this angle, angle E, is 5 bigger than angle B, right? X plus 5. And then this angle, angle H, that joins the two sides is X minus 5. So kind of the same thing as angle E, but angle H is 5 less than X. So if we were ordering these like in order from greatest to least is what they want, we would start with the biggest angle, angle E, because that's X plus 5. Then we would go to angle B because that's just X. Then we would go to angle H because that's X minus 5. So keep in mind the side that's opposite the biggest angle is the longest side. So since E is the biggest angle, FD is the longest side. Since B is in the middle, then that means AC is in the middle. It's the medium length. Since H is the smallest angle, then JG is the shortest side. So 32, write an inequality for the possible values of X. You're dealing with 2 triangles. Those 2 sides are congruent. Those 2 sides are congruent. The 2 angles that join the 2 sides are not. This angle is 64. It's larger than this angle over here, which is 61. What that tells me is then the side that's opposite that angle is going to be longer than the side opposite this angle. So 23 has to be greater than 3x minus 1. So for 32, 23 has to be greater than 3x minus 1. And now I just solve it just like an equation. I'll add 1 to both sides. 24 is greater than 3x. Divide both sides by 3. I get 8 is greater than x. But like I talked about in past videos, I like to write my variable first, and then I'll put 8 on the right. And if I flip-flop those 2 things, I have to flip my sign. So in this case, the inequality would be x is less than 8. Write an inequality for the possible values of x. Again, you've got corresponding sides. AC is the same length as DF. BC is the same length as EF. It's looking like these 2 angles, they're telling me angle B is 63. The angle that joins the 2 sides, that's 3x plus 6. The angle that joins these 2 sides is 4x minus 7. And then the side length that's opposite those 2 angles are 15.3 and 17.1. So the important thing that you're getting out of this is when you're comparing these 2 side lengths, DE is longer than AB. So what that tells me is that the vertex that's opposite angle F has to be larger than the vertex that's opposite the smaller side. So 4x minus 7, 4x minus 7 has to be larger than 3x plus 6. And now I just solve it. Subtract 3x from both sides. So I get, I get x minus 7 is greater than 6. I'll add 7 to both sides, so I get x is greater than 13. So there's that inequality. Construct arguments. Cameron incorrectly says the converse of the hinge theorem proves that the measure of angle S is less than the measure of angle W. So this angle is less than this angle. Explain his error. Well, with these two triangles, the only thing it's telling me is that the side opposite angle S is 12. The side opposite angle W is 13. 12 is shorter than 13. So Cameron incorrectly says the converse proves that the measure of angle S is less than the measure of angle W. Technically, since that angle is opposite the shorter side, you would think that that is the smaller angle, that the measure of angle S has to be smaller than the measure of angle W. The one thing that I'm seeing here, and I'm assuming this is what they're going for, is they're not identifying that those side lengths are congruent between the two triangles. They're not saying anything about that. They're just saying side lengths. If you go back and look at that converse, any of those examples, any of these examples here too, you'll note that they're showing that two sides are corresponding, and then the angle that joins those two sides are the one they're talking about. Here, they're not referencing any sides that are corresponding to each other, so I can't apply that hinge theorem or the converse of the hinge theorem if I don't know that those rules are being followed right off the bat. So as you're going through these, if you need anything, if you have any questions, feel free to shoot me an email. I'm happy to either answer you over email or meet up with you in Zoom, and we could talk about any questions you have.